Hello everyone, welcome back to Solid Geometry series. Today we will continue with orthogonal relations, and I'm having an exciting problem for you. Let S.ABCD be a pentahedron with a rectangular base ABCD, and SA is perpendicular to the base plan ABCD. Let E, F be the projections of A onto SB, SD respectively. A, prove that plan AEF is perpendicular to plan SCD. And B, prove that plan AEF is perpendicular to plan SAC. Feel free to pause the video if you would like to give it a try. Otherwise, continue watching for the solution. Note that plan SCD and plan SAC, they both have SC as their common line of intersection. So if we manage to show that SC is perpendicular to plan AEF, then we effectively kill two birds with one stone, right? In other words, we can take care of parts A and B together in one solution. Okay, moving on. So we have BC is perpendicular to SA by given, right? Because by given, SA is perpendicular to the base plan ABCD, so for sure SA will be perpendicular to BC. But in addition, we have BC is perpendicular to AB because ABCD is a rectangle. And therefore, we have BC is perpendicular to plan SAB, right? Because BC is perpendicular to both SA and AB. But if BC is perpendicular to plan SAB, then that means AE will be perpendicular to BC, right? Now that AE is perpendicular to BC, but AE is also perpendicular to SB by given. And therefore, AE is perpendicular to plan SBC. And from here, we can deduce that AE is perpendicular to SC. And we call this result number 1. Okay. Likewise, we have CD is perpendicular to SA. But CD is also perpendicular to AD. So that means CD is perpendicular to plan SAD. Therefore, CD is perpendicular to AF. Or to set it the other way around, AF is perpendicular to CD. But AF is also perpendicular to SD by given. So together, AF is perpendicular to the plan SCD. And from here we can deduce that AF is perpendicular to SC. And we call this result number 2. So from 1 and 2, we have SC is perpendicular to AE and SC is perpendicular to AF. So that means SC is perpendicular to the plane that contains both AE and AF, and that is plane AEF. Thus, any plane that contains SC will be perpendicular to plane AEF. Clearly, SC is the common line of intersection among three different planes, right? As you can see, that is plane S.BC, S.AC, and S.CD. However, the problem doesn't ask about plane S.BC, so we can ignore it. But clearly, SC belongs to plane S.AC and S.CD. And so, therefore, we have plane S.CD is perpendicular to plane AEF, and plane S.AC is perpendicular to plane AEF as well. One thing I would like to touch on is that this is something I should have mentioned before we even started the solution, and I apologize that perhaps I was too excited to jump into the problem. The solution. So in the problem statement, E and F are the projections of A onto SB and SD respectively. So projections, what that means is that from the vertex A, you draw a line perpendicular to the side that it mentioned. So in this case, from A, you will draw AE perpendicular to SB, okay? And from A, you draw AF perpendicular to SD. So that's what projections mean. Okay, just want to clarify. And last but not least, if you enjoy this video and if you want to see more videos like this, please consider helping this channel grow by subscribing to my channel. You can hit the subscribe button down below and giving this video a like. Your thoughtful assistance will help this channel reach a broader audience and will give me the motivation and the momentum to continue working on this long series. Thank you for watching, and I'll see you all in the next video. Bye bye now.